All right, this is question 9. Which value is equivalent to 2 to the 8th times 5 to the 9th times 10 to the 4th, all divided by 2 to the 5th times 5 to the 8th times 10 to the 7th? Well, to solve this problem, I need to use my exponent rules. So if I look at my first number here, or my first set of numbers here, I see that these have the same base. And when I have numbers with the same base, I subtract their exponents when I'm dividing. So I'm going to leave the base 2, and I'm going to do 8 minus 5, which is 3. Okay, then I'm going to look at my next set of exponents that have the same base, 5 to the 9th and 5 to the 8th. Well, I'm going to keep the 5, and 9 minus 8 is 1. I could write the 1, or I could just write 5. Lastly, I have my tens. So 10 to the 4 minus 7. Add the opposite. Different signs, subtract. 7 minus 4 is 3. Keep the sign a larger number. 7 is bigger. So I get 10 to the negative third. Okay, so I cannot leave this like this because it needs to be a positive exponent. So I'm going to rewrite this as 2 cubed times 5 divided by 10 to the positive 3. Another way you could have thought about this is if you're looking at the tens here, 10 to the 7th is bigger than 10 to the 4, and therefore it's going to end up on the bottom where 10 to the 7th is, and 7 minus 4 is 3. So none of this doesn't look like any of my answers yet. So I have to simplify. So 2 times 2 times 2 is 8 times 5 divided by 100 times 100 is 10 times 10 is 100. 100 times 10 is 1,000. Okay, right here, I should be able to stop and realize that my number on the bottom is way bigger. And so this is going to become a fraction. Or you could have said 40 over 1,000. Okay, divided both and gotten 1 over 25. So your answer should have been A.